Qualitative analysis question from June 15, variant 3.2. Again, we have to do the same things. We have to see if there is any color change, if there is any precipitates forming up, and the solubility of such precipitates. And again, where gases are released, they should be identified by a test and describe them in the appropriate box in your observations. Now, let's continue with the question. In the question, they have said FB6 is a solution containing two cations and one anion. Both of the cations are listed in the qualitative analysis notes. Select reagents to identify cations in FB6. Do tests using these reagents and record your results in the space below. Now, if we have to test cations, we have been provided with two of the reagents, which are sodium hydroxide and aqueous ammonia. These are the two chemicals we use to test cation. Therefore, we will make a proper table here where we will add these two reagents along with the observations we will record here, and then we will find out which cations are present in this FAB6. So these two reagents, sodium hydroxide and ammonia, are used to detect the presence of cations, where sodium hydroxide is used in these three steps. First, we add few drops, then we add excess of sodium hydroxide, and then again we warm the same test tube contents and test any gas liberating with damp or moist red litmus paper, because it can give you the presence of ammonium ion also. And ammonia is again second reagent, where we add first few drops and then excess. So let's perform this test. Now we will test Fa6 with sodium hydroxide. So first we will take 1 centimeter depth of this solution, and now we will add aqueous sodium hydroxide in two steps. First few drops and then excess. So this is the observation with few drops. As we add few drops, we can see white precipitates are forming, and if we add an excess of sodium hydroxide, these precipitates are dissolving. So these precipitates are dissolving. So the solution is again turning colorless. And now we will warm this test tube with damp red litmus paper. Put a test tube holder here, and then we will use damp red litmus paper. So this is the litmus paper. Damp this first. We'll put this litmus paper on the top. We will bend from the corners so that it won't fall. And now we will tilt the tube and we will warm. Now we will see for the color change of litmus paper from the center, the part that is exposed to the gases liberating, not the corners. Now the solution is warming and liberating gases. Bubbles are arising, and we can see the color of the litmus paper is changing and it turned into blue. It means the test is positive for ammonium ion also. So we have recorded the observation. White precipitates formed with few drops, which were soluble in excess, and then warming this resulted in damp red litmus paper turned blue. This means ammonium ion is present. So one of the cation is confirmed from here, that is ammonium. Now we are testing for the second ion, which has given observation with sodium hydroxide, but we will test with ammonia also, then we will confirm. Now we will take again 1 centimeter sample of this solution, and we will add aqueous ammonia. We will add aqueous ammonia dropwise first, followed by excess. So adding drop wise. White precipitates are forming from the bottom, and now if we keep on adding, those white precipitates are dissolved. Now we have one of the cation detected as ammonium. Now let's look for the other cation. Sodium hydroxide, white PPT, soluble in excess. Ammonia, white PPT, soluble in excess. So let's see, here we have zinc given, which is white precipitate soluble in excess and white precipitate soluble in excess. It means the other cation is zinc. So we have recorded that two cations are ammonium and zinc. So we will write here zinc 2 plus and ammonium ions are detected. Let's proceed with the next test in the question, which says, now the next part says the anion in FB6 is nitrate ion. Explain why it is difficult to confirm the presence of nitrate ion in FB6 using the method outlined in the qualitative analysis notes on page 11. Now if we see FB6, we have found contains the ammonium ion also. FB6 contains a cation, that is ammonium, and it contains nitrate. Here they have said it contains nitrate. So now let's look at both the test in the qualitative page. The test to see the presence of ammonium ion was basically sodium hydroxide was added and we have warmed. So the gas which has liberated turned the damp litmus paper. And if we look at the nitrate ion test, it says the same. The ammonia will be liberating with hydroxide, means sodium hydroxide. The only difference in these two tests are that in nitrate we add aluminum foil also, but in sodium hydroxide to detect ammonium, we do not add aluminum foil. So they are quite similar tests that we need sodium hydroxide for both of these ions. Therefore, it is difficult if a salt contains both of the ammonium ion and nitrate ions. It is difficult to detect these two ions simultaneously. But yes, we can detect in one way, that if we add sodium hydroxide and we warm, so first of all ammonia that is liberated will be because of this ammonium, and when the gas liberation finishes, then we will add aluminum foil and then we will continue heating, then again further ammonia will be liberating, that will turn the moist black litmus paper. So this is the difficulty here, so we will write this difficulty in this box. So we have recorded this detail here. Now moving on to the next part, it says, before starting part B, fill a half 250 centimeter cube beaker with water and heat with a Bunsen burner to approximately 60 degrees Celsius. You will use this as a hot water bath. Turn off the Bunsen burner. Now, I have kept here a beaker in which water is warmed, and we can see it's here. And now we will switch off this burner. We will just use this hot water for the tests. Moving on to this part B, in which they have said FB7 is a halogen alkane. Do the following test to determine the halogen present in FB7. Now the solution which they have given us here, FB7, is a colorless liquid, and we will see which halogen is present in this by testing in this way. To a 1 centimeter depth of ethanol in a test tube, add 1 centimeter depth of silver nitrate followed by 10 drops of FB7. After they have drawn a dotted line. Dotted line means you have to continue the test in the same test tube. Place the test tube in a hot water bath. So we will make all this mixture here and then we will put this in a hot water bath. And we will record both the observations in these two spaces. So let's perform this test. Now we will take a test tube in which we will add 1 centimeter of ethanol first. So it's the ethanol solution, and we will add 1 centimeter of this in a test tube, and here it is approximately 1 centimeter solution of ethanol. We will add silver nitrate 1 centimeter. So we have added 1 centimeter of silver nitrate, and we can see the color is not changing. The solution is still colorless. So there is no change happening. We have added 1 centimeter of silver nitrate. Now we will add 10 drops of FB7. So here is our FB7, and now we will add 10 drops here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see a very dense yellow precipitates are formed. Dense yellow precipitates are formed. We will swirl it a bit for mixing. And now we will put this test tube in a water bath. So here is hot water bath, and we have put this test tube here. And now we will see what's happening with this yellow precipitates. So no change is happening to the yellow precipitates. So we will record this observation here. So we have recorded the observations here. Now let's proceed on to the next part, which says the halogen present in FB7 is. Now let's see, if we have a carbon chain, like a carbon chain, the halogen could be chloride, it could be bromide, or in a carbon chain it could be iodide. So in chloride, bromide and iodide, we test in this way that we add silver nitrate, and if it gives silver chlorides precipitate, they are white. And if it is with bromide, the precipitates are silver bromide, and they are off-white to cream, off-white to cream precipitates. And if it's an iodide, so the precipitates are of AgI, and silver iodide precipitates are yellow precipitates. And also we write the ionic equation this way, that silver plus 1 from silver nitrate, when gets any halide as an aqueous phase, it forms silver halide precipitates. So this is the ionic equation for the formation of silver halide ions. Now here we have yellow precipitates formed. So yellow precipitate means iodide was present. So iodine is the halogen that was present in the halogen alkane. The next part says what type of reaction is the halogen alkane undergone. So if you see, the iodide from one of the carbon chain is displaced to the silver, it means it has displaced the iodine. Therefore, this reaction is termed as substitution. One of the thing is replacing, because it was actually AgNO3 which was added, silver nitrate, and this nitrate was actually replaced by iodine. So we call it substitution. So this is substitution mainly. Also we can say this reaction as hydrolysis, because it is an hydrolysis reaction also, because solution was used, and solution is obviously made up of water. So we are done with this part. Now let's move on to the next part in the question, which says FB8 and FB9 each contains a single cation and a single anion. Do the following test, record your observations. Now the first test is, to a 1 centimeter depth of FB8 in a test tube, add FB9 until there is no further reaction. Then there is a dotted line in between, means in the same test tube, we have to add aqueous barium chloride or barium nitrate. And obviously this barium chloride or nitrate is added to see the presence of sulfate or sulfite. So let's perform this test now. Now we will take a test tube in which we will take 1 centimeter of FB8, and in this 1 centimeter FB8 we will add 1 centimeter of FB9 until the reaction is complete. So once we add FB9, oh, fizzing is happening. It means it must be carbon dioxide. So let's test this gas if it is carbon dioxide or not. So in order to check that the fizzing that happened was of carbon dioxide or not, we will pass the liberating gas through lime water. So let's take this lime water in a test tube. And this is our delivery tube, which must bring the gas liberated to this solution so that it turns milky white. Now we will add the chemicals in the other tube and we will put rapidly the rubber bung there like this. We will put this rubber bung here. So let's quickly add FB8 first. Followed by FB9. But before we put FB9, we must put this rubber bung at the top, ready to be placed. So we can see bubbling and the liberating gas is coming to the tube, which is turning this content milky white. So the transparent solution become milky white, confirming that the gas is carbon dioxide. So we will record this observation. Now we have recorded this observation. Now in the same test tube, because it's the dotted line, we will add barium chloride to see the presence of sulfate or sulfite. Now let's perform this test. So in the content of the tube now, when the reaction is over, we will add barium chloride solution, like a few drops first. So as soon as we add barium chloride, the solution is forming white precipitates. So we will record this observation that white precipitates are observed, means sulfate or sulfite are present. Now, once we have added FB8 in FB9, we get fizzing. It means one of them, FB8 either or FB9, must contain any acid and the other one must contain a carbonate salt. Therefore, when carbonate reacts with acid, it gives off carbon dioxide and water. Therefore, the cation detected must be from any acid, that is H+, and carbonate from any salt, means CO3 2-. After this, we have observation with barium chloride, and that is white precipitates. So barium chloride with white precipitate observation, we can conclude that, and sulfate or sulfite must be present. Sulfate or sulfite must be present. They haven't asked you to confirm, or else we have a test to differentiate in between sulfate and sulfite. Now let us also write the ionic equation. Once FB8 has reacted with FB9, in which one of them contains acid, so we will say H+ of one reagent has reacted with the carbonate of the other reagent, and this gives you water and carbon dioxide. So we have observed carbon dioxide in this way. In order to balance this equation, we will put here. Now, if we are writing the ionic equation for the formation of these white precipitate, it means barium 2+, which was actually taken as aqueous, has reacted with either sulfate or sulfite. So I'm writing here sulfate, aqueous of salt, and they have formed white precipitates which are of barium sulfate. So these are the white precipitates. So these are the ionic equations if they ask you. So here we comes to an end of 15 marks qualitative analysis question.